Alright everyone, so here's the last video from the factoring packet we did on block day, January 9th and 10th. So this section is taking all the things that we learned from the previous lessons and kind of compiling it together and adding in the factoring that you just learned on the previous video, or on the previous part if you were there that day. So we've got our equation here, it's in standard form, which means we're going to have to actually factor it to get it into the intercept form that we want. Now I know that the intercepts are already written for us, but we still want to be able to practice it so that we can do it on our own. So we'll start by finding factors of 5. Easy number because it's a prime, so it's just 1 and 5, which is awesome. So here's my double bubble groups there. Put x's in front, 1 and 5 in the back. And remember, you can always just pause when you need to. You don't have to just watch the whole video all the way through. You can pause if needed, if you need to catch up or write stuff down. Now I know that it has to multiply to get positive 5, so it's going to have to be the same signs, either positive times positive or negative times negative. Those are my only two options. Since I also need it to add up to positive 6 though, I'm going to put positive 1 and positive 5 there. So there's my intercept form of my equation, which matches up perfectly with my intercepts because x plus 1, if I was to set that equal to 0, that would mean that x equals negative 1, which is exactly what we have here. And if I set x plus 5 equal to 0, which this, by the way, is a review from the previous videos, the previous lessons we did, should not be new content. Then the other thing we have is x equals negative 5, which is our other intercept. So go ahead and plot that on your graph. Got negative 1, 2, 3, 4, negative 5. So there's my two intercepts. Now our y-intercept we talked about, I'm just going to draw an arrow for that x-intercept part. Y-intercept we've talked about previously is where it crosses the y-axis, so somewhere on this line. Now think about all the points that would be on this line. If I put a dot here, this would be 0, 1. This would be 0, 2, 0, 3. Kind of getting the idea there. What do they all have in common with all those points? Well, they all have 0, but what spot is the 0 in? It's in the x spot. So I'm going to put a little note down here that says x equals 0. Alright, well if x equals 0 for everything on the y-axis, which is where my y-intercept has to go, then let's plug in 0 and see what we get, because that should tell us our y value for our intercept. And I can actually almost do that mentally, but I'll write it out up here. So if I plug in 0, 0 squared plus 6 times 0 plus 5. So what's 0 times 0? That's just 0. 6 times 0 is 0. Plus 5 means that our y-intercept is at 0, 5. So 1, 2, 3, 4, 5 right there. So there's our y-intercept. If you understand the concept of the intercept and the x equals 0, it's a pretty easy thing to figure out. I mean, plugging in 0 is one of the nicest numbers to have. It's pretty great. Now, we already wrote an axis of symmetry for you, and it is at negative 3, cutting through the x-axis. But let's say we didn't hand that axis of symmetry to you. How in the world would you find it? How did we actually figure that out? Well, if these are my two x-intercepts and it's a line of symmetry, that means it's got to be the same on both sides, so it should be right in the middle of the whole parabola. Well, my x-intercepts kind of reflect over each other, so that line of symmetry has to go right down the middle of the x-intercepts. I'm going to put that as a little note for myself. Axis of symmetry is in the middle of the x-intercepts. That's how we figured out it was that. And remember, it has to be x equals that number. You cannot just put negative 3. It's the whole line, so it's x equals negative 3. Now that's pretty helpful because the very last thing that I need in order to finish drawing this, because obviously I don't have my full U-shaped parabola here, is I need that vertex. Okay, now, well, how can I use that axis of symmetry to help me find the vertex? Well, the vertex has to be somewhere on here, right? Vertex is in the middle of the parabola. It has to be on the axis of symmetry. Well, let's say it was right here. That would be negative 3, 1. This would be negative 3, 5. Negative 3 down there. Hopefully you're kind of getting the hint that all of those have negative 3 in them. Okay, well that's because the axis of symmetry has to be the x value for the vertex. You can't have it any other way. If you don't, you're not going to have it on the axis of symmetry like it's supposed to be. Okay, well that leaves me trying to figure out what this y value is, which means I'm going to have to plug in negative 3 into my equation to figure out what that y value is. Now I can do one of two things. I can put it in standard form, or I can put it in intercept form. I personally think intercept form is a little bit easier to work with, so I'm going to take negative 3 and put it in place of x because it is the x value. So it's going to be negative 3 plus 1 instead of x plus 1 times, instead of x plus 5, negative 3 plus 5. Well, negative 3 plus 1 is negative 2. That's going to be times negative 3 plus 5, which is positive 2. Negative 2 times positive 2 is negative 4. So that means my vertex is actually negative 3, negative 4 right there. And then we draw a parabola through. Nice, lovely U shape. Just like that. Alright, now the last two things mentioned here are domain and range. And it's been a little while since we've talked about those, so let's do a quick refresher. Remember, domain, we use these kind of bars to help us remember. And it's all of the x values. So basically what domain is going to tell us is what are all the possible x values my graph could possibly contain. Okay, well I obviously have x values at negative 3 and negative 2 and negative 4. Okay, but what if I keep going? Now at negative 10, there's no point on my graph, but there's something super important at the end of the parabola. Right here we've got an arrow, and what that means is that this arrow actually takes the graph further to the left and up forever and ever. So even though I don't actually have points on my graph that I drew, there are actually points somewhere kind of up here that I can't see, and it's going to keep doing that forever and ever this way. Because of that, that means my domain is negative infinity on the left-hand side, and because there's an arrow over here doing the same exact thing going this way, that means I'm going to have x values all the way over here into positive infinity as well. So that's what my domain is. Range is going to be the opposite. Range is bottom to top. Now this is not going to be infinite. By the way, this domain is the same for every single parabola that we will do this year. Once you get into more upper levels, you'll start to do ones where they're sideways, but for ours, they're always going to look like this. Now range does not have infinite values on both sides. So if I look at my picture and I look at my y-axis, okay, down here I've got negative 10. Are there any points at negative 10? No, I'm not hitting anything there. In fact, I don't get anything until I get up here, which is right here. That's the bottom of the graph. The lowest y value I can possibly hit is negative 4. So that's the bottom of my range. And it keeps going up here, up here, up here. Now I could draw a line here, but what do those arrows mean? It's going to keep going up. So no matter what I do, there shouldn't really be a bar because it's going to go up forever. So the top of the graph is positive infinity. It's not going to stop, and it's going to keep continuing up. Remembering my range is my y values, domain is x. Please make sure to get that copy down. Press pause if you need to, rewind if you missed something. You're going to pause after you get all your notes, and then you're going to do this example. So I'm not going to go over it. You need to try it yourself. If you want to check with me, you can. That's fine. And then when you're ready, go ahead and hit play. And I'm going to go through this third example, but you need to do the second one first. If you have issues, go back and watch the first example again. Okay. So, hopefully you've tried that second one now. I'm going to do this third example, and then you'll have the fourth one to do. That's part of your practice assignment. So again, this one, notice there's no intercept form given for us, so we got to factor it ourselves. I'm going to factor this guy. It's 1 and 1. Pretty easy. Start to build my parentheses, and I get x and x, 1 and 1. Okay. Hopefully this one's pretty easy to see the signs because it's all positive numbers, so these are going to be all plus signs in there. So go ahead and pause and fill those in. Now I'm going to need to solve for my x-intercepts first. Now, since both of these are x plus 1, I really only need to solve it once. So x plus 1 equals 0. And I get that x equals -1. So my only x-intercept is at -1, 0, which is right there. All right, now we'll kind of go back to that in a little bit. Well, actually, let's talk about that right now. Change my mind. So that's pretty significant because we've always had something where x-intercepts are 2 of them. The parabola always crosses twice, whether it's, let's see, I'm just going to draw a quick picture here. See if it'll let me move it. So whether it crosses here, there's 2 x-intercepts there. If it's down here, there's 2 x-intercepts. If it's here, there's 2 x-intercepts. We haven't done anywhere they're up here, but then there wouldn't be any x-intercepts. So take a couple seconds. Where would I have to put this parabola so that there's only one x-intercept? How do I have to make that work? I can line it up like this, but then there's an x-intercept over here. So think to yourself, where do I have to put this to make this work? Hopefully you're starting to get the idea, because here is what it would look like. The only way for there to be one x-intercept is if my parabola sits exactly on that spot, which means that x-intercept isn't just the x-intercept. What else is it actually for this special parabola? If it's the one point, the lowest part of the parabola, the exact middle of it, it also happens to be the vertex. So this is one of those kind of special cases. Doesn't happen a ton, and you may not necessarily see it on a quiz or anything for a while. We like to kind of throw those in there just so you can see what those special cases would look like. Alright, so now we're going to progress to the next part. We've got our y-intercept. Remember, that's where x equals 0 because it's on the y-axis. So if I real quick take that 0 and plug it in up here, 0 squared is 0, 2 times 0 is 0, plus 1 is still just 1, which means my y-intercept is at 0, 1. Hopefully that's an easy one to plug in. Now I've only got 2 points, but let's use my axis of symmetry to help me out. Axis of symmetry usually is in the middle of the 2 x-intercepts, but I don't have 2. It always goes to the vertex though, so it is at x equals -1, going right through that vertex. Because it's the line of symmetry, it's got to be the same on both sides. So if there's a point here, there better be a point right on the opposite side. So that's where I can draw my third point in, even though I don't have another intercept to use. Real quick with domain and range, remember this is always, always, always the domain. That's the x values, so everything left to right. Range is a little bit trickier. That's bottom to top. That's the y values. So look at your range. What's the lowest y value my graph is hitting? Right here, that would be 0. And then it goes forever up, so it's positive infinity. Do the other examples for practice now.